So good morning to everyone. Is it audible?
Yes, sir.
Yes, sir.
Okay. So today in this session, I'm going to give a brief note about the applications of GS in planning. So we are all very much aware about planning is most important in every development or before we commence any work for successful. We need planning. So in this regard, the spatial planning is the utmost important one in all the fields of our life. This application of remote sensing and GIS in spatial planning has given a big scope for efficient planning. Means if you look at what is spatial planning, it is a strategic organization of land use because the land is very limited and it is most important resources for the development of the humankind. And the proper utilization of land is very much essential for us. And with the application of GIS and remote sensing, we could able to make a most efficient way of planning. So it is not only just related to the one aspect of the planning. I'm going to give the details of about the various types of planning which we are involved in. And most of my talk will be about a little bit of theoretical aspect, and most of my talk will be from my own research work. So it balances competing economic, social, and environmental demands to shape a physical environment effectively. So it is for the development of economic as well as for the society, and also for the environmental demands. The spatial planning is most effective and it is very much important. So here, why spatial planning matters means it prevents urban sprawl. So actually, when we look at the urban development or the spatial growth of any cities, we see there is unorganized and clumsy and most haphazard development. So that kind of a planning means that kind of a development can be properly planned and it can be stopped, the haphazard development of the cities. And also it boosts economic efficiency, because economically means when the planning is done properly, automatically there will be a good economic progress. So in any field, because even if it is a road or if it is any kind of economic activities, there will be good development and economic progress will be there. Means planning is the most important, and it is very much seen from the means the post GS and remote sensing era and before what it was. And it also promotes environmental sustainability, because the environmental sustainability means we know sustainability is the key element now, because we are overusing the natural resources. So in order to curtail the overuse and to protect biodiversity and mitigate climate change, so again the spatial planning with the help of remote sensing GIS is very much crucial. And it also improves public health, because of the proper planning. There will be clean roads, clean drinking water, clean parks, clean air. So all these things can be developed through proper planning. Means if you look at the various countries, especially the Western countries, we see this remote sensing and GIS based planning has brought a tremendous improvement, and we can see the clean city and whatever that is listed here. It gives a clean air, safe drinking water, parks and healthcare facilities will be more. All that we can see in the Western countries, but in India still we are stepping towards that, but not completely, because most of the cities are overpopulated and there is no proper planning. So it also optimizes infrastructure. So it coordinates the cost-effective placement of utilities, roads, and public transit system. So one of the best thing is that we can make the cost-effective planning using the remote sensing and GIS. And it also very good for disaster management. It prevents development of high-risk zones, which are the areas which are prone for flooding and also landslides, and also the protection of the wildlife. So I'm going to, because I have handled almost most of these areas, I have done research and I'll be giving my own research outcome. So when we look at into the types of spatial planning, we can classify into broadly three types: as macro level remote sensing and GIS based spatial planning, meso level remote sensing and GIS based planning, and micro level remote sensing and GIS based planning. Because when we consider the space, the land will not be confined, it cannot be confined to the administrative boundaries as we have in India. It is natural factors which will be demarcating or which will be the deciding factor in planning, spatial planning. So from this aspect, we can have a macro level, because if I say that macro level means one unit of physical aspect, like say for example, the mountains. The mountain region can be one basis for macro level planning. So in other ways, it can be the meso level means within the mountain we can take a part of the different type of soil condition can be a meso level planning, and micro level it can be even to a village level. So this kind of spatial planning can be up to the extent of the entire country as a whole or a state as a whole. So usually means most of the national level projects will have, it is highly macro level planning, but macro level investigation, macro level research has been done. Meso level means we can means even the state is can also be considered as the macro level, and meso level means it can be a district level or one watershed. Means usually we take one watershed as a criteria, because in land the land is determined by the climatic factors and the physical factors. So these climatic and physical factors can be neatly obtained by the remote sensing data, and we classify the watershed as a planning area. So likewise, the one river, the entire river basin can be a meso level planning, and micro level means the minor watersheds can be called as a micro level planning. Means this micro level planning can be brought up to the level of the sub watersheds and village level. So that is the most beneficial aspect of the spatial planning using remote sensing and GIS. I'll be talking about what is remote sensing and GIS also. Just I wanted to give the importance of the spatial planning. And the types of sustainable based spatial planning, we have agricultural land use planning. Means agriculture. Today, agriculture is the backbone of the entire country. And we know that the food security system is totally dependent on agriculture. So just agriculture until some 2 decades back, it was a traditional way of cultivating crops. But after the introduction of remote sensing and GIS, the agricultural land use planning has made a wonderful growth, and we could able to sustain our own demands. See, there are many sub-analysis like crop suitability analysis, crop management, and the crop management means you, without going to the field, you can sit within your room and you can monitor what is happening to your crop. So whether it is the moisture content is less, or if there are any insects that is attacked to your crop. So whatever the maintenance is required, that can be maintained through remotely. That is, the crop management can be neatly done with the application of remote sensing and GIS. And coming over to the water resource management, again, this water resources is again a very limited resources, and it is it should be efficiently managed. The surface means we have surface water management and also underground water management. The surface water management means the lakes and rivers. So we have several lakes and rivers, but if you look at the condition of the lakes and rivers of India, none of the rivers or lakes are not potable, because we have totally polluted and we have not managed it properly. So when we use this application, we can maintain our surface water resources to a very good extent. And so also the underground water. So we have dug a lot of bore wells, and we are losing our underground water. See, the underground water is actually confined. It should be fixed, and it should be allocated only for the major trees to grow. If the underground water is good, the trees will be can survive. If the large trees, if survives, it can protect the medium level and flow level plants. So that's how it can maintain, the whole region can have a very good ecosystem. So the underground water management is most crucial today, but we are failed in this aspect also. So, and land use and land cover planning. This is another very big area of research, land use, land cover. As I told you, all land will not be fit or suitable for all type of purposes. So also we cannot misuse the land. The land which is more suitable cannot be used for means it cannot be overused. So in this aspect, the land suitability analysis can be done, and we can definitely allocate the various types of land for various purposes. That is another important aspect of spatial planning. And the spatial temporal analysis, this is another major thing, means we can come to know what is happening over the period of time, means whether the land use change is taking place, whether from agricultural land to barren land, whether the region is going towards the barren condition, or it is going from agriculture to the non-agricultural or residential or urban development. So this is another important aspect of planning, because if we do not keep track of what is happening to our land use condition, definitely we are going to have a serious problem in the future. From this aspect, the spatial temporal analysis of land use should be kept monitored. So that is another major aspect we can see here. And urban planning, as I in the beginning told you, the road network planning, the solid waste management and planning, drinking water distribution network planning, allocation of urban assets planning, example, the bus stops or banks or post office, whatever we have in today, we call it as the urban assets. So those things can also be neatly planned, where exactly the bus stop should come, where exactly the bank should be put, where exactly a railway station should be put. So in this way, the urban planning can be done neatly by remote sensing and GIS. And urban sprawl means the expansion of the city itself, in which direction it should be planned to grow. Because when we lose control of the urban sprawl, definitely it will bring a lot of mismanagement, and the city planning will be totally collapsed. And we see, even for that matter, Chennai or Delhi or even Bangalore. So to some extent, Mysore is neatly maintained, but urban sprawl in all these major cities, it is totally out of control. So that should be planned properly. And the forest resource management and planning. So we have the forest fire mitigation analysis and planning, and forest cover and deforestation monitoring, biomass and carbon accounting and inventory, forest volume and even carbon sequestration capacity analysis. So all this can be done in a meaningful and more successful, and which can be for the betterment of the future. Disaster mitigation and planning, flood inundation modeling and mitigation, landslide susceptible mapping, where the landslides are going to take place, which are the susceptible places of landslides, earthquake and tsunami impact planning, vulnerability analysis, desertification. So these are all the major disaster aspects, and these areas have been neatly researched, and planning and solutions have been given. So then coming over to the regional planning, the physio-agroclimatic classification of regions and analysis. Means physio-agroclimatic conditions means actually taking the, just earlier they had done only based on the climatic classification, the agroclimatic classification, but future agroclimatic classification will provide much more detailed information about what type of area is suitable for what type of crops or what type of land use. So that is the major, because a region will have, means we see some certain regions will have good economic prosperity and progress. Some regions will not have that much of economic development. So all these kind of regional imbalances can be, we can remove the regional imbalances if the proper regional level planning is adapted. So regional disparity analysis will be best suitable for that. And as I already mentioned you, the food security analysis, because the regional planning determines the food security system. So if you do not have your own food in your own courtyard or in your own village, what is the use of having many other things other than having a food? So we are totally neglecting this aspect also. From this point of view, also the remote sensing and GS analysis will provide a very good food security system, how we had to maintain and which are the food crops that has to be grown and what is happening to our production yield, everything will be studied. So with this, I just see this image is a satellite image, and can you make out what it is? Is it possible for any one of you to tell what this image is describing? Hello.
We are seeing now, but I could not express our views. No, nothing. We don't know that this.
Sir, is
Okay.
it a delta? Is it a delta-like place?
It's not a delta. Yeah, but it
These are
is.
houses.
Excuse me.
Houses.
Houses. You're talking houses?
Yes, sir.
No. This is a satellite image of a stream paths. I just mentioned about a river basin will be a best planning area. We cannot take a district or we cannot take a taluk. It is totally a human created boundary line, and that cannot be a good planning area. So usually in geomorphology and geography, when we take up any regional level planning, we take the natural parameters for the planning. Here, these are the actually if I if I move the mouse, can you see the mouse movement?
Yes,
The cursor movement?
Yes, sir. Yes, sir. Yes, sir. We are seeing.
So these are all the first order streams. So the first order, the second order, and we finally see actually there is a water body, accumulated water body, means water accumulation, and we can see further. So this is the first order, second order, third order, fourth order, fifth order, and the sixth order will be the major river. So we take these aspects into consideration. See this here, these first order streams are coming from the elevated land, and this is the water divide or the boundary line between the two river system. Can you see this? This is the elevated land. This is the water boundary, and the water is dividing between the two directions. This stream is moving towards the upward direction, means towards this direction, and the other one is coming towards this direction. So the land here is the elevated land, it is the water divide boundary we call. So this is how we demarcate the boundary line. We do not take the taluk or the district boundary line for our planning area. We will be taking the natural boundary because the entire climatic condition is reflected in this, because I can talk about 1 hour in over this image. So how we can interpret this image with respect to climate, with respect to rainfall, with respect to soil condition, with respect to underground water. So just let me give some brief note about, and let me go with a little bit of questions. You need not to worry about answering. If you know the answer, you can answer. Otherwise, you can just. So looking at this image, how do you consider this area, whether it is having good rainfall or minimum rainfall or no rainfall? As I told you, this
I think
image.
it is a minimum, sir. Normal condition, it will come like this.
Okay.
Normal. So no abnormal things, either positive or negative.
Okay.
It is a normal one.
Yes, very good. And what? How about the groundwater? Underground water?
Groundwater.
That could be also low, sir. Groundwater.
Low.
Low.
Okay. And soil condition,
Soil condition is good only.
okay.
So
Yeah,
red
just
soil, normally red soils are good.
okay.
That's why
Yeah,
for cultivation purpose, it is a good soil.
okay. So just by looking at this image, you could able to give visual interpretation. Most of the thing what you have said is right, because we can see all this green thing is river path, and it is moist area. Moist area. So when we see this moist area so neatly seen, means it is having good rainfall, and the groundwater is also excellent one, and the soil condition actually we have zonal, azonal, and intrazonal soils. Means adequate drainage system produces good soil condition. So a best soil region will have good drainage. Means if soil has to develop into a nutritious and the best soil, means it should have good drainage system. So this the closely seen the drainage pattern, or the very good network of the stream paths is a good indicator of good drainage system, and that will definitely develop into a good soil. So this is how we go with the satellite image interpretation. Means this is a visual interpretation, but we use the software tools in order to make it much more vigorous interpretation and analysis. Just I have to change the PPT. I will just change. Hello.
Yes, sir.
Just a minute. I'll just call our staff.
Okay.
Madam, welcome. ನಂದು ಇದು ಅದು PPT. ಅದಾಯ್ತು ಸ್ಟಾಪ್ ಮಾಡಿ. So if you have any questions, you can ask in between. I do. ನಾನು ಇದು ಪೆನ್ ಡ್ರೈವ್ ಓಪನ್ ಮಾಡಿ, ಇದು ಪೆನ್ ಡ್ರೈವ್ ಅಲ್ಲಿ ಇದಲ್ಲ ನೋಡಿ. ನಾನು ಬೇಕು ಎಲ್ಲದು ಹ್ಮ್. ಓಕೆ ಓಕೆ. ಇನ್ನೊಂದು
ಮೂರು ಹೇಳಿ.
ಜಸ್ಟ್ ಇಮೇಲ್ ಓಪನ್ ಮಾಡ್ತೀನಿ. ಅದು ಇಮೇಲ್ ಓಪನ್ ಮಾಡ. ಒಂಥರ ಐಡಿಯಾ ತಗೊಂಡು ನಂದು ಓಪನ್ ಮಾಡೋದಿಲ್ಲ. ಯಾವ್ದು ಆ್ಯಡ್ ಈಗ ಇದು ಮಾಡಲ್ವಾ?
ಈಗ ಮಾಡ್ತೀವಿ ಸರ್ ಅದು.
just this lesson. ಕಂಟಿನ್ಯೂ ಎಲ್ಲಿದೆ ಇದು ಈಗ ಡೌನ್ಲೋಡ್ ಮಾಡ್ಕೊಳ್ಳ
ಹ್ಞೂ ಸರ್ ಇದೆ ಅಲ್ಲ ಸರ್ ಅದಿರೋದು
ಇಟ್ಟಿದ ನಾನು ಈ ಫಿಗರ್ ನೋಡ್ಲಿಲ್ವಲ್ಲ ಹಾಗಾಗಿ ಈಗ ಅದು ಬೇರೆ ಇತ್ತು
ಹಾಗಾದ್ರೆ ಬೇಡ ಸರ್ ಡೌನ್ಲೋಡ್
ಬೇಡವಾ
ಅಲ್ಲೇ ಇದೆಯಲ್ಲ ಸರ್
ಮಾತ್ರ
ಇದೆಯಲ್ಲ ಸರ್ ಇದು
ಹ್ಮ್.
ನಿಮಿಷ ತೋರಿಸ್ತೀನಿ ಇದು ಅನ್ಸುತ್ತೆ. ಇದು ಸರ್
ಓಕೆ ಇಲ್ಲಿಂದ ಬಿಡು
ಇದೆಯಲ್ಲ ಸರ್ ಅಸೈನ್ ಔಟ್ ಮಾಡ್ಬೋದು
ಎಲ್ಲಿ ಡೌನ್ಲೋಡ್ ಮಾಡು
ಇದೆ ಹಾಕ್ಲ ಸರ್
Yeah. So let me just explain about how a disaster can be managed. So this is a general work, and then I'll go on to my research work. So a disaster can be defined as a sudden or unexpected event that causes widespread damage or loss and exceeds the community ability to cope. Disasters can be caused by natural, man-made, or technological hazards. So the characteristics of disaster is suddenness, magnitude, impact, and it also the scope. The effects of a disaster, it will have a huge impact on human loss, including death and injuries, material loss, economic losses, environmental loss, and the disruption of basic services. So here, when we come to the significance of remote sensing and GIS, what is remote sensing? Remote sensing is used in disaster management to monitor, warn, and respond to disaster. It can be used in all phases of disaster management, including prevention, preparedness, relief, and reconstruction. So the applications of remote sensing, you see monitoring, warning, response, planning, risk assessment. So how it works? Remote sensing can provide real-time information about disaster over large areas. This information can be combined with data from other sources such as maps or measurement stations using geographic information system. Usually, we get the satellite image in this format, and this satellite image will be loaded into the software such as software such as ERDAS, SNAP, or GRASS, or E3C, and we develop the spatial data. Right. The remote sensing is nothing but the data obtained from the space without having any physical contact. The information about the Earth obtained from a remote object, that is remote sensing. So when the remote sensed data is sent to the Earth station, it will be processed, and that process image will be of this kind. So means visual interpretation, it will be very difficult for a small scale map. It is too difficult for us to see the visually we cannot interpret. Only major elements can be visually interpreted, but most of the micro elements cannot be interpreted. So it will be used through the software. and the software will provide us a very good amount of data. So a satellite image will have a scope of different various data. Means, and we also use different sensors to acquire or capture the various types of data. So let me just give you a brief information about how this particular GS and disaster management works out. Means if you see it in this figure, in this diagram, we see the various applications are done, and at last will come out with a final output. So I do not want to go in detail, and just let me brief you about how GS is helping remote sensing, because remote sensing is only data provider, whereas GIS is a data processor. So what the data what we have obtained for a region or a place or an area, that will be processed through the GIS software, and this software will give a useful information in the form of output. The map is the final output of this GIS product. So in GIS, we see on the various components, like the people will be there, the hardware, the software, the data, and the methods used in order to process this data. And the final output will be the solution in the form of final decision supporting. Means GIS is also called as the decision supporting system, because taking enormous amount, means more than 100 variables, we cannot come to a conclusion by human brain. Whereas by using the software, we can easily, even if it is 100 or 200 or 500 parameters or variables, we can make a significant output. Means which parameter is most significantly influencing on what. So that kind of information can be obtained from the GIS, whereas remote sensing provides only the data. It is the sources of data. It is a easy way of getting data. If a person has to go around the entire city and collect the data, means it will take several days. Suppose if you want to go and find out for survey the whole district, means it will take several months and years. But remote sensing will be providing it within a one means depending upon the configuration and the area, we can obtain it within one image, or it can be about 10 images. So it all depends upon. So it is a data provider. Remote sensing is nothing but a data provider, and GIS is a software analysis. So when this data obtained from the remote sensing is fed into the GIS software, and we can make a lot of analysis. As I told you, the crop suitability analysis, the land use planning analysis, the disaster management and vulnerability analysis. So all this analysis can be done in the GIS software, not in the remote sensing software. But certain remote sensing softwares are also having some minimum amount of analysis. So that is also means it is a blended format of software, both remote sensing data processor and as well as the GIS analysis applications is also available in certain softwares. So let me just give you a brief note about the different types of remote sensing. So why is remote sensing useful? It covers large area. The sensors can measure energy wavelength beyond range of human vision. Means what we cannot see or what we cannot get, that can be obtained from these sensors, the different energy wavelengths, and record information in real time. Because if I send a person and to collect data, I'm not sure whether he's providing a proper information or not. But here we get the real-time data. Means if I say that this is the condition of the cloud condition of Mysore city at this hour, means it is a real-time data. There is no any kind of error in it. So that is another major advantage. Means we get all information in a real time, and there is no scope for error. It is only this error, means only human has to do the error, or if there are some cloud cover, if the information is not properly captured, means if the wavelength differs for water body, if the wavelength is differing and it may give some other feature. So that kind of a error may occur, but if it is captured in a clear daylight, then there will be no error, and we'll get accurate data. So this flow of material, how the remote sensing material and analysis would be done in our research area means the basic basis of remote sensing and the types of satellites will be used. Different types of satellites are used for different capturing of data. So say for example, for vegetation, there are different satellite sensors are there. For especially for the building, there are different type of for mining activities, there are different type of sensors. So likewise for ocean means for fishing and climatic condition monitoring, there are different type of satellites and sensors. So the types of data varies according to the satellite sensor, and this will be brought down to the means regional level, and it will be done using the GS, and finally it can be up to the taluk level or even village level. So here we find this satellite data, how we obtain and how it will be processed in this. Actually, the sun is the major source of energy, and whatever the sun rays that falls over the earth, that sun's energy will be reflected back, and the reflected back energy will be captured by the sensor in the form of a wavelength, and this wavelength will be again sent to the Earth station, means Earth process, means the Earth receiving station, just like ASN. We have a Earth satellite information receiving station located in ASN. So that's how the satellite will what the wavelength that it is captured, that captured wavelength will be sent in the form of a data to the Earth station, and the Earth station will be processing and finally we'll get it in the form of an image. So what the images I have shown you, that form of an image will be obtained in the at the G level. So this is how the satellite processing works. So the sun is the source of energy, and based on the sun's energy, whatever because we know that as we have the camera in our smartphone, so the camera also does the same similar type of work like a satellite sensor. When we expose our camera, immediately whatever the reflected wavelengths that reaches to the sensor, that will be captured. If I just capture a scenery, so different items will be there, different objects will be there. So different types of trees, different type of natural and as well as man-made things will be there, buildings. So each and every object will have a different reflected energy. So that reflected wavelength will be captured by the sensor, and that will form into a photo. So similarly, here also the sensors will be capturing it from a very far away distance, and it will whatever the data that is captured, that will be sent to the Earth station, and from the Earth station it will be processed, and the satellite image will be developed. So it will be having both the physical image as well as the software data will be produced. So software data will also be there, and the physical image will also be developed. So you know that EM spectrum means the electromagnetic spectrum is there in the sun's rays. So that is the major basis for it is the with the electromagnetic spectrum only we could able to get the entire process done. So I do not know this we have in the whole sun rays, we have different type of wavelengths. So among the wavelengths, the visible spectrum is only a very small area. So that is 400 nanometers to 700 nanometers, and all this VIBGYOR, all the items that what we see through our eyes, will be only in this particular wavelength from 400 to 700 nanometers. And as the means if the sun rays are quite brighter, the wavelengths will be smaller. If it is lesser the sun ray means energy, sun is energy, it will be quite broader. So the visible spectrum will have, as I told you, it will adjoining within this electromagnetic spectrum, we will have the X-rays, the gamma rays, the ultraviolet rays. All these wavelengths are now utilized in remote sensing in order to get the various types of information about the Earth. So visible spectrum is most importantly for our land use, land cover planning. We use this visible spectrum, and this is, as I told you, it is the 0.4 to 0.7 nanometers, and the longest visible length wavelength will be in red color, and the shortest will be in violet. That's how the VIB-GAIA or the when we see the rainbow, we get all these 7 colors, and that is when the shortest wavelength interact with the smallest particle of water molecules, it will produce violet, whereas the longest wavelength will be interacting with the larger particles, and it will be having the red color. So in this way, we find the different wavelengths have different colors, and based on this, we get the image. And so reflected and thermal infrared means, as I told you, it is not only visible wavelength, but also the thermal infrared wavelength is also taken into account for various types of analysis and for detecting various type of earth resources. So the microwave region is another region. It is nowadays it is extensively used in our remote sensing analysis. So this is see the passive remote sensing and active sensors. The passive remote sensing means when the sunlight is there, the whatever the information that is captured by the sensor, it is called as the passive. And whereas during the night time, when the sun sets, after that, if we are capturing the Earth information, it is called as active sensor. Here, the satellite itself will send the light or the energy, and the reflected energy will be captured by the sensor, and it is called as the active sensor. And we know that there are different type of satellites like geostationary orbit satellites, near polar orbit satellites, and so this is geostationary orbit satellites are fixed to the Earth station. Geostationary means, say for example, our TV programs are all run through the geostationary satellites. The satellite move in accordance to the movement of the Earth, means the Earth rotation. The satellite also rotates in phase with the Earth's rotation. That is called as the geostationary satellites. And whereas the near polar orbit satellites are the common satellite that will be providing information about the Earth. So the spatial information as well as the temporal information means earlier a satellite used to take 22 days to cover to come over the same spot. Now it is not 22 hours, it is even within hours. There are many satellites which will be going over a single place. So that's how we do not lose information. We have information for every just 10 minutes we have information. So that's how it has become so significant. It means it is so important because we are getting the whole world or the earth information in the matter of every hour. So whatever the changes that takes place within the hour, we can able to detect it and we can have the data of it. So that is how the near polar orbit satellites are doing. So the spatial resolution, there are various types of resolution. We have the spatial resolution. Spatial resolution means the what object is detected, means what is the size of the object, and the size based on the size of the object, if the satellite could be able to detect. Because earlier, I'll just go on with this slides, you can able to understand. You can see the animatic data, roads, buildings, and driveways are neatly seen. You can see these are the roads, and there are certain buildings, and there are smaller buildings, and even the large buildings are also there. So this is the spatial resolution. Whereas earlier, 80 meters resolution multispectral data used to look like this pixels. Can you see the pixels at the back? So these are the 80 meters resolution spatial data. This is very much difficult for us to know what exactly this particular image is providing. And over a period of time, we could able to have much advanced technology and sensors, and we could able to get much more greater configuration and resolution images. So this is 80 meters. All these pixels are having different colors, and the road is passing, but we cannot able to identify a road properly in these pixels. So there are buildings that can also not be able to identified by this 80 meters pixels. Means one pixel covers 80 meters of land or the surface area on the earth. So nothing can be so accurate in 80 meters resolution. So later on, it came down to 30 meters, and you can see the pixel size has been got, means smaller and more number of, means when 30 meters means 30 meters of area on space. Say, for example, if a building is of 30 meters of area, that will be covered in one pixel. So that much of smaller resolution we had, means 30 meters pixels could able to give much more detailed information than 80 meters. And later on, the spot data, that is 10 meters. This is the French satellite. Satellite was the first thing sensor to get 10 meters resolution, and you can find there are certain dark and very light patches, which is means the pixels cannot be identified. The pixels are got merged, and we are seeing it in the form of dark shades, and 3D like images are seen. So this was much more good for getting detailed information. And you can see this road area is quite dark in color, and where there are certain buildings, there are some light in color. So this kind of a building area in white, and some road area also in white, and rest of the thing is in gray and black. So this is 10 meters resolutions for spatial information. And 1 meter, it become much more clear. You can see there are certain vegetation kind of a thing, means whatever we could not able to be identified visually in these 10 meters, we could able to identify in 1 meter resolution. And there are certain some kind of a rectangular water body, human created water body, or something which is seen here. And there are certain dark patches which can be considered to be as the vegetation. And the building aspects are also seen. The buildings are quite visible now. And when it comes to the submeter, means 60 centimeters resolution, 60 centimeters resolution. So now we see the natural thing. What is exactly what we see on the ground? The same thing this satellite is sending us, like a photograph. So you can see the green patches and also the white patches, and much more clarity is available in this. And this is much more, means looking more closely. Now we have 30 centimeters resolution image, and now whatever the driveways and all these roads, everything is clearly visible, and also the buildings. So that's how over the period of time the satellite image technology has grown up. And looking more closely at a resolution means if it's we can easily make out from this image what this particular object is. This is an airport, and these are the different gates, means where the flights come and actually it will put into the bay. So this is the actual airport, and here we have the number of bays for the flights. So that's how the airport could able, means by looking at this image itself, we could able to say this is the airport and this is the runway. So and there are certain buildings, there are certain vegetation. So that's how the satellite technology has given much more detailed information. Here, see, this is the 1 pixel level. This is 1 pixel level. So what is actually this entire 80 meters resolution could able to get means it was a very small bit of land in the 80 meters resolution, but now 1 pixel itself is getting a larger amount of information. So let me go with these pixels, and so this is 80 meters pixel, which is which used to cover the whole area into 1 pixel. Don't consider this is the size of the pixel. This is the area that 1 pixel used to cover, and later on this 80 meters to 30 meters, it is this pixel size got reduced, and then for sub 10 meters, it is much more smaller. The pixel size got smaller, and it is this is for sub-meter resolution, and we have got even a very small pixel covering a small area. So whereas earlier the small pixel used to cover a very large area, but now means you had to imagine that this very small dot itself was 80 meters area earlier. Now this small dot like pixel is covering a very small area. Earlier, one small pixel used to cover larger area, but now the same pixel level could be able to cover a very small area. That's how the satellite, means spatial resolution, got improved. And we have the different types, means in India, which are how the Indian satellite remote sensing technology grown in India. It is there, and we have, means earlier 80 meters resolution to the very small size pixels. And see, this is you cannot say this is a satellite image. This is the satellite image taken from the satellite only. So the 30 meters resolution will give this way. This is 30 meters resolution satellite image, and based on that is what we see in the spatial resolution gives what area and how detailed it is. Whereas spectral is about the colors or bands. As I told you, the different wavelengths produces the different bands, and this spectral resolution is also very much important. And as I told you, the different wavelengths are captured for different objects. One satellite sensor itself cannot capture all types of wavelengths, and there are specific satellites sent with specific sensors in order to capture certain particular wavelengths. So that's how the spectral resolution also has tremendously changed. And the temporal, as I told you, from one season to another season. Say, for example, all agricultural scientists and people who are researching in agriculture field need to have the season-wise information. What was the type of land condition during the rainy season, the post-rainy season, the pre-event, the pre-rainy season, or say, for example, if you have flood, before the flood, what was the type of land? And during the flood, how much of land has been submerged? After the flood, after 15 days or 1 month of flood, which are the crops that are standing, which are the crops that are totally vanished? So that kind of a temporal data we can get from the temporal resolution. And the radiometric, it is the color depth. Again, as I told you, the sensor, the more accurate and information if you need, means the the sensor has to be very much perfect, and it will give the color depth, because say for example, all vegetation will be in red color, but we have different types of vegetation. So all we cannot categorize. We can say this all red color is vegetation, but where is coconut tree, where is paddy field, where is sugarcane field? All this type of information can be obtained only when there is a radiometric resolution is in good. So mm, already I have told you about the applications, and there are a number of applications, and what I have listed out, it's that itself is not the thing. It will be much more detailed applications are there. So just this is a satellite image, and you can see clearly certain information we can visually obtain. So if I ask you, you will also able to answer to many of my questions. So what the green patches are representing. So this is means we have two types of color combinations: false color combination and true color combination. This is the true color combination, actually based on the wavelength, and actual the based on the wavelength, how it interacts with the atmospheric thing. Vegetation will be shown in red color. Actually, all satellite images will show the vegetation in red color, but that will be transformed into, converted into the true color. So this is a true color satellite image. So if you look at this image, you can able to make out how good is India when compared to the rest of the places shown in the in this satellite image. Can you just, if anybody answer certain questions, that will be good for me, that you are really able to understand what I am explaining. So can you tell me which part of India is more dry rather than
Western part, sir. Western.
yes. So we can easily see the Thar deserts, which is having a kind of creamy, a kind of a color, and the mountain regions and the coastal belts is having dark green, which is indicating good vegetation. And there are certain parts of Eastern Ghats is also having vegetation, good vegetation, and other places are almost dry in condition in Karnataka. And when you compare the entire southern India, this part is moderately good, whereas this is most dry, which is the northern part of means Tumkur, Sira, Chitradurga, all these regions comes over here. And this is, as you know, that the Western Ghats is having good vegetation and good rainfall. Means vegetation is a good indicator of rainfall also. So from this image itself, we can make a lot of interpretation. Which part of India is having more rainfall, which is having most dry condition. So all this information, and also you can see the Arabian deserts are also there. So this Gobi deserts of China. So all this information we can able to get only, see this big area is obtained from the satellite image, and we can able to get the whole information in one shot, in one single picture. So this is the advantage of remote sensing. So as I told you, in order to get much more detailed information, certain sensors will be capturing most driest places and the wet places. And here you can see this Africa, the northern part of entire Africa is a desert, as well as the Arabian deserts. This is northern part of Africa. This is yeah, Kalahari Desert, and you can see in this India, we have the Himalayas having a greener patch, whereas the rest of the India is having almost light yellowish color. It means that India is not as good as this South Africa, the Mid Africa, or the Himalayas. So it is a moderate, it is having a moderate type of a climate condition. Either it is not too dry or too wet. So that can be just interpreted by visualizing or analyzing with rest of the areas. And you know that these are the snow covered areas which is having white patches, means the cold climate, means the polar and cold type of a climate. So what we can classify, either based on the vegetation, we can say that evergreen forest, semi-evergreen forest, deciduous and dry. So we have only from this image we can based on image vegetation we can classify this number of classifications. Based on the wetness we can say that this is humid area, this is humid area, subhumid area, semi-arid, this is arid. So based on the temperature, based on temperature and wetness we can classify. So also the soil condition can also be identified and classified. This is called the macro level remote sensing, because we do not get detailed information, but we get the entire larger area with lesser information. So if you come over to the India, we can see this is the heat where the concentration of nitrogen dioxide and air pollution. So the air pollution, say this is Delhi and this is this part of Allahabad and Varanasi and this. So we can see where the air pollution is more on which date, which time. So that kind of information also be obtained from this remote sensing. And this is regarding the what the climate weather condition. So can you see this is a cyclone that is which has happened. Means there are many cyclones will be taking place in the ocean, but only those cyclones which come and hit the land, that only will be broadcasted. Means we have the news of those cyclones or hurricanes that come and hit the land. So what I mean to say is the remote sensing technology is helpful for covering the climatic and weather condition, also monitoring the weather conditions. And coming over to the agriculture, water resources and land use satellite. See this is the crops in India. Means if you look at the entire India, the cropland of India is more in the southern part, and there are certain eastern part, and Indo-Gangetic plains is not having that much of green patch when compared to all this area. So the crop area means we can assess whether the production of this year will be good, or it is moderate, or it is deficient. So all this information can be obtained from the satellite images itself. And see here we find the water stress. So what is actually India is having 54% of water stress, and all this dark red color is indicating too much of water scarcity. So all this information will be very good for how to plan. Spatial planning can be done. So which areas to be attended, in what crop should be grown in that water stress area. All this kind of planning can be done based on this kind of information. And the flood areas. So which are the areas which is having regular flood? Means every year flooding takes place. So if you look at this, means the northern rivers are highly flooded, and also the coastal belts are flooded. So here there are certain patches which are flood areas in Kerala. And in Karnataka, there is no much. Because of it is a very small scale map. We could not able to identify the flood in the Karnataka. Means the macro level area we have taken for flood analysis. If you go for detailed only Karnataka, we can able to see much more flood area, and it can be even up to the Talakal village level. So likewise, the different this is heat wave zones. So heat wave, how the heat wave is affecting the northern parts of India, the northern plains. So whereas the heat wave is not that much severe in the southern India, whereas the central and the northern part of India is having high severity of heat wave. Yeah. So from satellite image, how we are going to get the data? Means this is the output product. This is the satellite processed output. Satellite captured information, finalized output product. This is what we call satellite data. But this is the GS based output product. So what we are able to see in 1977, there are certain green patches and there are certain green patches here and there. And over 1989, the green patches has increased. And in year 2002, it has increased much more. Means it is clearly showing that there is a tremendous change or transformation in the growth of vegetation from 1977 to 2002. So the satellite images, if you look at these satellite images, as I told you, the red patches are vegetation area. The red color is indicating vegetation. So that's how this is the spatio-temporal analysis. Means it is giving spatial a particular place of different periods. It is particular place is spatial and temporal is of different years. So even population change can also be detected through satellites. Here the population change in 1972, 1986. Just you see the city growth. So population growth means without having a building, man will not live. So he has to build a house. So that's how the spatial growth takes place. So based on that, we can also estimate what is the population size of this particular city. So, okay. Now let me get into what different types of remote sensing based analysis and research I had done. I'll just go on showing you certain things. And see, this is earthquake susceptibility analysis on done in the year 2014. So what we did, we had taken the satellite image and the satellite image based on the water. These are the wards. The city has got 65 wards, and these 65 wards have been yes, mapped, and the satellite image is overlaid, and we have captured what type of building is existing. Means analysis the building information, which are the oldest building wards. Means it is there will be mix of buildings, old and new buildings, but we ask the software or the program to give the buildings which are very old, more in number, 70% of the area having building more than 50 years or 100 years. So that kind of analysis has been done, and we have obtained the area which is having most oldest buildings, because if there is an earthquake, which will be the area that will be most susceptible to earthquake, means the oldest buildings. So the buildings which are having very old construction will definitely fall, and if the earthquake happens during night time, definitely without any precaution, the people will die. So that's how we had done the earthquake susceptibility analysis, taking the lineament into consideration, and based on the lineament, we have identified which are the most vulnerable areas, and within this vulnerable area, which are the most vulnerable with regard to the magnitude of the earthquake as well as the oldest building. So this is how we can able to inform or provide the information to the administrators that these are the areas which are more prone for earthquake, and there will be heavy damage of means loss of life and property. So that is how we have given output. And Another major project I had done, what I had done is the degree of desertification in India, that is especially Karnataka, related to Karnataka, means I had done the process of desertification. Desertification means earlier the definition of desertification was confined to the spatial expansion of the deserts in the periphery. Did you get my point? This way, what is the desert that is existing today, whether it is the Thar deserts or Kalahari or Atacama or Gobi or the Sahara, all these deserts, they will expand its territory because of the wind movement. The expansion of this boundary of these deserts is called as desert. It was defined as desertification. But I took the same word because I didn't find any suitable terminology in order to express or narrate the condition, what is happening in Karnataka. Because when I just took, means when with my geographical and geomorphological and climatological knowledge, when I just saw the entire Karnataka, I saw that this entire region is having a transformation. In my own region, we had the subhumid kind of a climatic condition. From subhumid, we have from my school days, it was subhumid. From subhumid to semi-arid. So the climatic transformation has taken place. Climate change has taken place from subhumid to semi-arid. From semi-arid to we are now accepting towards arid. This is what the desertification is, because the area which is having a climate change, it will show its indicators through various forms. It can be through the vegetation, it can be through rainfall, it can be through the decay of or the total vanish of the biomass, especially the animals. So this kind of a transformation or the climate change, when the climate change is taking place, these indicators will be we can clearly identify the not only rise in temperature or reduce in rainfall, but also we can see the overall change in the vegetation and animal life. So that kind of observation triggered me to take up a research work on, and I denoted that as a desertification because a place or a region having a transformation from humid to subhumid, subhumid to semi-arid, semi-arid to arid, arid to dry, and dry to desert. So this is the stages of climate change. So finally, a land will be converted into a whole desert area. So if you look at into Karnataka, it is totally happening. In my own region, it was happening, and I collected the satellite image data, and when I analyzed it, to my surprise, it was the second most larger area under arid condition in India. Rajasthan is the first arid state. Area under arid condition is Rajasthan. Means area under arid condition, larger area under arid condition is in Rajasthan. The second arid area found in Karnataka. This is when I narrated this and explained to some people, they are not ready to accept my views because they said that Karnataka is having very good vegetation, because people will see only the Kodagu or the Western Ghats and the mountains and the rivers, but actual condition is totally different. So that's how the Karnataka, later on, it was even included in the NCERT books that Karnataka is the second most driest state in the India. So these are the drainage pattern. Means I'm just telling you, means I am explaining how I could able to derive the most desert prone or area which are very much in a serious condition, which is not in a position to retreat back. That kind of a patches I have identified. So for this, we have taken means the forest cover information from satellite images, and this is the drainage network system, and this is the rainfall information, and the aquiferous system. What is the type of the geology and the groundwater situation? Because groundwater is the major root cause for desertification. So if there is no good groundwater, definitely desertification is 100%, it will happen. So the drainage density, so which are the places having good drainage density? And ultimately, because this is not only this information, there are many parameters I have taken, but I have kept only the few parameters which is quite logically and commonly understandable to all. And the final output map is this, which are the places which is having severity of desertification. And you can easily see these Western Ghats and the coastal regions are having green patches and semi green in these areas. This is, we call it as the transitional zone. It is either Malnad nor it is plain area, it is semi Malnad and having a mixed type of condition, whereas these places are having dry condition. That too, the dark red color is most driest area in Karnataka. So these patches falls in the Tumkur, Sira, and what Chitradurga and all this region, and here the Belgaum patch. So this is Chamla region, and this is Pavagada and the Tumkur region. So these are, and I have identified up to village level. Here I given only the taluk level information. So there are I have made it three types of classification: moderate risk, high risk, and very high risk. And the which are the high risk taluks means I have listed out, and I can read out here. This is the high risk: Bidar, Atar, Anekal, Koppal. So there are many. Even the southern part of region, Chamnagara, Krishnarajanagara, Hoskote, so Mysuru, Hasan, all these places comes under high risk only. So this is to one particular taluk like Gundlupete taluk, which is actually the Gundlupete once upon a time was considered to be the evergreen forest, and even today most of the elephants, tigers reserves are found in this place. But it has become, means the climate change has taken place, the deforestation has happened, forest is shrinking because when there is no groundwater and no rainfall, when there is no surface water as well as the groundwater, certainly the forest will shrink, it will dry. And even I have identified which are the places which has lost its vegetation and what is the loss of vegetation, the deforestation has taken place. So why this particular place is having so much of desertification means it is also due to the wind that is blowing from the Eastern Ghats. So I do not want to get into detail because of the rain-bearing winds are pushed by the wind gap. I call this as a wind gap. There are the combination of the Western Ghats and the Eastern Ghats. In this gap, the wind comes in a more vigorous way, and the velocity will be more. And during the rainfall, the clouds will be pushed off, and this is again causing because of the vegetation, the loss of vegetation, this wind system has become more vigorous. So what has happened in this area? See, I have taken this mid Kabini basin. In the Kaveri River basin, I have taken only the mid Kabini basin. It is a part of this Kaveri subwater system. The earlier, this area had, during 1993, there were 871 lakes. 871 lakes. So this is Gundal sub-watershed, 245 lakes, Nugu watershed, 43, Upper Kabini, 188, Middle Kabini, 97, Lower Kabini, 288. So all together it was 871. And what has happened in 2021? Just we completed this project only 3 years back, and the result was shocking. Only 235 lakes are existing, 636 lakes have been vanished. Now they are encroached. Just you can imagine if the natural water bodies are just dry up, how much of environmental impact it will lead to. So there is a severe drought condition is existing in the surrounding area because of the dried lakes, and people are started migrating from those areas to the other parts of the city. So this is how the impact analysis can be, vulnerability analysis can be studied by using remote sensing and GS. And to talk about the urban planning, I did it for Mysore City Vision 2100. Now we are in 2026, but this was done in 2014, and it was for 2100. How Mysore City should be planned. No doubt, Mysore City is planned city when compared to rest of the cities of India. But when compared to uh, the present condition or the land use activity that is going on, definitely it is shocking, and the city is going to lose its balance, because if the proper planning, spatial planning, urban planning is not maintained, definitely the city will become it will become just like a slum. So what we have today, a good place of living, that will be polluted, and it will be already solid waste management is not happening properly. Drinking water supply system is not happening properly. Air pollution is going beyond its control. So likewise, there will be a lot of environmental impact if the city is not planned. And I have planned it for the whole, means I have taken about 50-kilometer stretch of area. And what you see, these are all the river, major river. This is Kaveri, and this is Krishna Sagar Dam, and this is the Kaveri. And I have omitted out the buffer zone, because a river on either side of it is for 5 kilometers, it will be having good water supply and irrigation and agriculture. So I have omitted out this river path on either side 5 kilometers. So I have taken rest of the area into consideration, and based on the geomorphological analysis, I have even you can see there are certain round dots, like these are the villages. Even the villages of 5 kilometers boundary has been omitted out, because I cannot take or consider the village area for my planning boundary, because what I plan on the map, that should not overlay on existing some village settlement. So I have omitted out the entire villages. These are all the round omitted thing is village settlement. So these are the concentric circles for each zone. What is the type of land, whether it is elevated land or slopy land or steep slope land or a moderate slope land, what is the groundwater. Based on this, you can see these are the index. So commercial area, where the commercial area has to come, education, the schools, where the schools should be put, where the forest or vegetation should be grown, where the health should be kept, because near to the next to the residential only the health should be there. Next to the health and residential, the school should be there. So this is how the priority based modeling of land use has been done for the entire city, but no means our either the Mysore City Development Board or corporation or the state officials are not interested. They are not bothered. They are only worried about the other aspect. They are not worried about what is going on. So this is how the entire city priority model, sector model, and the concentric model, which is this is for every 5 kilometers, how it should be modeled. This is priority based, and this is and there are sector models. I have made three types of suggested three types of model of city planning. So if that happens, definitely there will be no any kind of environmental loss. The health issues will not be there, air pollution will not be there, water pollution will not be there, solid waste management problem will not be there. So all these aspects are taken into consideration in order to do this planning. So this is how it is done, and this is about the landslide which I had done in Uttarakashi. The Uttarakashi is known for landslide, and just when I was in Dehradun, I was taken up a research work in this particular place of Himalayas, and this is how the geology, geomorphology, the digital elevation model, slope aspects of the direction of slope, and all these are all put together, and analysis has been done, and which is the most susceptible area where the landslides will take place. Because if I happen to give the entire Himalayas for to give which are the particular places or region which will have landslides, means I'm not going to consider the whole of Himalayas. I'll be considering only the places where the dwelling is there and where the serious impact will be there on the human interaction or communication. So I can instead of beating a bush, I'll be taking straight away filter it out and take only the areas which will be prone for landslides, and within that which are the most vulnerable. So that kind of a vulnerability analysis means landslide vulnerability analysis can be done. This is one aspect of that area, and you can see this is the peak of Uttarakashi hillock, and this is the Uttarakashi town, and the Ganga is flowing here. The river Ganges is flowing, and this is in between. It is this Uttarakashi is in a sandwiched condition. Here, if there is a flood, this township will be affected. If there is a landslide, also this township will be affected. So I have means done lot of means these are all the data that will be generated from the satellite image. See, so it looks the satellite images looks like mere picture, but we get lot of data, and based on this data, which are the low, moderate, and high risk zones have been identified, and afterwards, what should be the immediate action to be taken place? Which are the most immediate buildings that should be vacated? Means the people living in the buildings that is also done. This is the high risk zone buildings. So buildings means it can be residential or it can be public or any type of. So all these buildings are under high risk zone. This is mapped. So what is the total loss? What is the total built up area, and what is the total buffer zone, and what is the population? 1,120 population is living in that high risk zone. That should be limited. In case in the event of any landslide, what will be the total loss to the entire region? So that is that is also estimated. So this is how we can plan for disaster, for water resource management, for crop management, so forest management. So there are many applications, and I can go on with many more work, and just for time being, I'm concluding. And if you have any specific questions, you can go ahead. And I thank you very much, all of you, for your patient hearing. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you,
Sir, I will
sir.
give you
Thank you.
a
Thank you very
bit of
much.
time.
Thank you, sir.
Thank you.
Thank
Sir,
you
I will
very
give
much,
you a
sir.
vote of
Thank you,
thanks
sir.
regarding.
Thank you, sir.
So, behalf of all participants, I extend our sincere thanks to Professor
Thank you,
Arun Das,
sir.
sir. Thank you, sir, for delivering such an excellent and informative session on applications of remote sensing and GIS for spatial planning. And also, you discussed with us what is GIS, remote sensing, satellite resolutions of pixels, visualizations of images, and also you discussed about your research works, earthquake, landslide, dissertations, and all things. We are deeply grateful to you for sharing your valuable time and knowledge with us, sir. Your insight during these sessions have truly inspired everyone in this MMTC program. Thank you so much, sir.
Thank you. Thank you very much. Thank you very much. Thank you.
Yeah, thank you.
Thank you so much, sir.
Thank you. ಎಂತ ಇದು ಇಮೇಲ್